Hi, everyone, and thank you for joining me today in this session about protecting your apps from code to cloud and back to code. My name is Jim Armstrong. I'm a Senior Director of Product Marketing at Snyk. And today I want to walk you through a bit of the problem space here that we see and how we can improve the security of our applications and the cloud at the same time. It wasn't that long ago that a full stack developer was somebody who could develop the front end of the application, the UI and those kinds of things, as well as the back end of the application. I think now with the introduction of cloud becoming more and more prominent, that's also might include the actual technology stack as part of the full stack development, meaning that they develop all of that code for an application, but can actually develop all of the cloud infrastructure and cloud deployments as part of that as well. Now, whether that's a single person or not is a matter of resources and expertise in individual companies. Certainly in a lot of companies it's different, but the cloud does start from code. And so the issue of how we fix cloud problems becomes more and more of a code issue, of an engineering issue, something that can, fortunately, be fixed much earlier in its life cycle instead of waiting for the cloud itself to be deployed. But of course, the cloud is there in service of the applications. Those two things go hand in hand. So splitting them apart doesn't really make a lot of sense. Unfortunately, that tends to be something that we see, on a fairly frequent basis, where there is, a plan and perhaps some tools and a process for code security that's focused on the developers, and a plan and maybe some tools and processes around cloud security to protect the infrastructure and the running environment. But a lot of those two things are disconnected from each other, when again, in reality, what we want is to have all of this flow together. The idea of DevOps is that we can produce these applications quickly and deploy them quickly, and that means both the cloud and the app configurations and code all need to go together. They need to be tested together. They need to have pipelines that at some point come together to produce the application as it runs in the cloud. And all of that needs to be secured early and often in its life cycle as well. The advantage, or one of the advantages at least, of developing the cloud that way, of using infrastructure as code, is to have that early source of truth so that it can actually be tested. Now, the other sort of prickly point here, the other sort of hidden issue, although probably for most of you listening today, this is not such a hidden issue, is the fact that the developers far outnumber security folks. So one of the other reasons why shift left has become such an important concept is that we want to move that responsibility to the left, not just the testing itself, although getting earlier visibility into security results is certainly nice. But we actually want to shift that responsibility. There are nowhere near enough security experts to be able to handle all of the security alerts and events that might come out of the code for the application or the code for the cloud configurations, for that matter. And so it's very much on the developers, and you could swap out the word developer for cloud engineer, to be able to quickly identify issues and be able to quickly fix those issues. That's the other really important aspect of this, because that's how we're going to scale security, is by getting those developers involved. Now, again, when it comes to applications and application code, there are fairly well-known and fairly well-deployed patterns for making this happen. We have the code and we test it in our developer's IDE. We test it again when it's in the code repos. We test it as it goes through pipelines. If there are artifacts that are created, they can be tested wherever they're stored. And then finally, we can test our apps as they're running in the cloud. Again, none of that is new to the world of applications. However, we don't always treat our cloud that way. In fact, a lot of times with the cloud, we start at the other end. We start at the cloud and we look at what's deployed there. And we've got to make that connection back to code. That's really, really important. Now, we're seeing more and more coverage that goes from code to cloud, meaning, we can check things in both places. We can check for the cloud, we can check the infrastructure as code. We can check our Terraform configurations, or we can check a container, even a Docker file early in its life cycle. And then we also look at what's deployed. And so we identify issues across the life cycle. But really, we want to link issues across this entire life cycle. The great thing about having all of this in code, your container configurations and your infrastructure as code configurations, Kubernetes, all that kind of stuff, is we can identify those issues early in the life cycle. And then, of course, we want to link those things to the cloud, because how do you fix problems that you identify in the cloud? You have to come back to the code and fix them just the same way you do with your application issues. So if you're only doing one or the other, or if they're not linked to each other, you're not linking your cloud resources to the IAC that creates them, or the containers that are being created there, then it's going to be very hard to fix the actual issues themselves. It's a lot of manual work to go backwards that way. So really what we want is we want to have this code to cloud coverage, but we also want to go from the cloud back to code. And what that really means is a couple of things. One, we want to have a single policy engine. So if we start at the code side, which is the appropriate place to start, right? Let's catch problems before we deploy anything. We want to have a policy engine there. We want to be able to identify our policy in code as well, so that we can check everything that's about to be deployed. But we also want to use that same policy engine with what is deployed, with the things that are actually running in our cloud environment. We want to apply the same checks in both places throughout the life cycle of those resources that we're defining and deploying. Critically important, if we're defining two different sets of policies, obviously we're going to get two different sets of results, and then we're going to have to do all the work again to match those things back up. So that single policy engine is really important. Now, again, that's part of the code